Okay, good morning, sixth period pre-calculus students. I guess it's not morning anymore. I don't know what time it is for you guys, but I found a way that I can give you guys your lesson even though I'm not there. You might not like it, but that's okay. So let's go ahead and get started. If you remember last time, what we learned is we learned how to take a derivative. So here is the, say, a function x to the fifth. And if I take the derivative, remember we use this little apostrophe, and we read that apostrophe, we say prime. So that's f prime of x. And the rule is that you bring that power 5 down, x, so it's 5x to the fourth. We subtract 1 from the exponent. So you bring the old power down, 5, you bring that down out in front of x, and you subtract 1 from the exponent, so it's now x to the fourth. So that's what's called the power rule. So power rule, we learned that last time. And now we saw something last time that maybe kind of piqued your curiosity. So let's consider, so I'm just going to say consider f equal x to the fifth over, say, maybe something like x cubed. Okay, so the question is how do we take a derivative of this? So we want to know what is f prime of x here. So the rule for polynomials is that you bring the power down, you subtract 1 from the power. That's the power rule. So that's what we know. So some of you might wonder, can I just bring the power down of the numerator and bring the power down of the denominator? So that might be something that you want to know if you can do. So something like this. Maybe this is what we want. But so first, let's simplify. Let's simplify this function. So this is going to be, if you subtract, this is x to the 5 minus 3. Remember, you subtract their power, so this is x squared. But we know that the derivative of x squared is really just 2x. So this simplifies to be 5/3 x squared. So one of these has to be the right derivative. Which one is it? Well, it's not this one. So why? Why? Well, the algebra here, this is correct simplification using algebra, and we know that this derivative is correct. So something strange is happening here. It's not exactly clear what's happening. So what's happening, we have a fraction, and we want to take a derivative over a quotient, a fraction. Here's another example. So one more before we get started on the notes. So what if I have a function like this? We'll say f of x equals maybe x to the fifth times x to the, let's say, seventh. And we want to know, can I just use the product rule on each one? So maybe the derivative, f prime of x, is equal to 5x to the fourth times 7x to the sixth. Maybe. So this is what we want to know. We don't know. Is that right? So well, let's first simplify the function over here. So this is really, you add the powers. So x to the 5 plus 7 is x to the 12th, like that. And now if we take the derivative over here, this is going to be 12 x to the 11th. So which one's the right derivative? This right here is 35x to the 10th if you simplify. So the answer is that this one is not the correct derivative. So there's something strange happening with products and with quotients, with a fraction. And so that's what we want to talk about and study today. So let's look on the next page here. So we want to learn the product rule and the quotient rule. Now, the process of deriving these formulas is a little bit long, and I'm not going to show you because I think that would be a little bit painful. Remember, the way that you derive this formula here, that I'm just going to plop in your laps, is you use that definition that we talked about last time. So remember, f of x plus h minus f of x all over h. That's the definition of the derivative. And this is actually how you would derive this product rule formula. Let's go ahead and look and see what this product rule formula says. It says if you have a product of two functions here, f and g, then the derivative is going to be, this is strange. Have a look at the derivative. And the rule says that f gets its derivative first. While g right here, notice g's waiting. And then we say plus, so plus, and now g gets its derivative while f is waiting. It's like they're taking turns with the derivative, or they're dancing or something with the derivative. So now they take turns and they trade. So let's actually do an example. So here, this one, I'm going to underline this one right here, and I'm going to call this one f. And I'm going to underline this one here and call this one g. Okay, so now the rule says that f gets the derivative first. So let's take the derivative of this guy first. So that's going to be 6x. You bring the power down, the 2 comes down, hits the 3, and then plus, remember this is 2x to the first, so you bring that 1 down, you multiply it to the 2, and you have 2x to the 0, which is just 2 to the times 1. Okay, so this is f prime. Now, what does the formula say? If you look back up here at the formula, it says multiply. So now f got his derivative, and g is just waiting patiently beside f prime. So let's just copy and paste. I'm just going to copy and paste g. This is g, no derivative, just g. Now the rule says plus, product rule says plus. And then we have g prime is next. So now let's write the derivative of this guy over here. So that's the derivative of 5x is just 5. This is g prime. And remember, the derivative of a constant like 7 is 0. So that's gone. So we just have 5. 5x to the 0, and the x to the 0 is just 1. And now the last thing that we want to write here is f. So just copy and paste f. So we'll paste f over here just like this. There we go. And this ugly thing is the derivative. Yikes. So no wonder our answers were wrong before. Something wasn't working. If I go back to that previous page here, so if I wanted to take the derivative of this f using a product rule, I would have to let x to the 5th get his derivative first, while x to the 7th is waiting. And then plus, now x to the 7th gets his derivative, while x to the 5th is waiting. So x to the 5th. So this is the proper derivative, apparently. Well, let's see. Let's combine them. X to the 4th times x to the 7th. That's x to the 11th. And over here, this is x to the 6th times x to the 5th. That's 7x to the 11th. If I add 5 and 7 together, I have a total of 12x to the 11th, which is what we found before. So the product rule is a little strange, but it's something that ends up being true, unexpectedly true. So before we look at this rule, I don't want to look at that rule yet. Let's go do some product rule examples down here. So notice number 1 has a fraction. So that one's not a product. Number 2 has a fraction. That one's not a product. Number 3 and 4, these have multiplication between these two, which imply that these use the product rule. So this is f, and this one's g. And so now let's use the rule. So the rule says, maybe I should use a different letter than f since f is already taken, but f prime. So I'll just, we'll use f just as a kind of a filler letter there. But let's take first the derivative of f. So f gets his derivative first. The derivative of x is just 1. The coefficient's 1, x to the 0, and this negative 1 disappears. So this is f prime. times g prime, the derivative of g is 2x, there we go, plus, so this is f prime, this is g prime. Now, I've already broke the rule. What does the rule say? G has to wait. I didn't let g wait. So g has to wait, so let's just copy and paste g plus. Now f is waiting while g gets his derivative. So this is f prime g plus g, let's see, what is this guy here? This is f g prime. All right. So they have to take turns. They have to take turns. Let's look at this next one. So this is f, and this is g. Okay, so now the rule says that f gets his derivative first, so let's take the derivative of f, the 3 comes down, subtract 1 from the power, derivative of minus 3x is minus 3, and then the derivative of the 1 is 0. Now g has to wait. G waits patiently like that, plus. Now now g gets his derivative. The derivative of g is just 1, and then f waits. So here's f. Let's just copy down f. No derivative. And this is it. Let's just leave it like this. Leave them like this. I wouldn't simplify it. I'm afraid if we try to simplify, I'm afraid if we try to simplify, we might break it or something. So let's just leave it like that for now. You could simplify x squared minus 2 plus 2x squared minus 2x. There we go. And then combine the x squares. You have a total of 3x squared minus 2x minus 2. Yeah. Does that factor? Not that we have to, but I'm just kind of curious. I don't think it does. Factors of -6 that add up to be -2. No, it doesn't. Okay, we're not going to simplify this guy. No, just leave it alone. Okay, well, let's go look at that other rule. Yikes. Let's look at that other rule, the quotient rule. This one is a little different than the product rule for sure. It's less like a dance and more like a mess. So what does it say? So notice here the denominator is g and the numerator is f. So g is, sometimes we call this one the low function. It's the function in the denominator, and this one's the high function. It's in the numerator. And so notice the low function comes first, g of x, and then we multiply by f prime. So the derivative of the numerator, quotient rule says minus. We have a minus. F comes next, and then G prime. So there's a little kind of ditty that helps people remember this. We usually say low d high minus high d low all over low squared. So over low. So low d high minus high d low over low squared. So what does that mean? The d means the derivative. You're taking the derivative of that one. So low, you take the denominator, and then d high, the derivative of the numerator, minus high, that's the numerator with no derivative, and then d low, that's the denominator's derivative, all over the denominator squared. What a mess. So let's actually practice it here. So let's use our formula. I think I'll switch colors here. So this one, the numerator, I'm going to use blue, and in the denominator, I'm going to use green. So remember, the formula says low, or g of x. So low, that's 2x plus 5. Now the next part of the formula says d high. So that's the derivative of the numerator. Take the derivative of 3x squared. That means you have to bring the 2 down and multiply to the 3. That's going to be 6x, just like that. And the derivative of the 7 is 0, so that's nothing. And then the quotient rule says minus, and we want high d low. So we got to write down the numerator, that's 3x squared minus 7, and then d low, we have to multiply by the derivative of the denominator down here, which is just 2. Okay, now low squared, that's just the denominator, no derivative. Denominator squared, no derivative. I'm just going to leave it like this because I'm afraid if I start simplifying, it's going to fall to pieces and I'm going to start doing wrong algebra steps. There's no problem with simplifying if you really want to. It's not hard. It's just kind of like work. It's all it is. 14 plus 14. Got to watch out for that, distributing the negative. Plus 14 all over. Let's leave this. I'm not going to expand that guy. And then you can simplify the numerator to get a total of 6x squared plus 30x plus 14. 6 times 14, trying to factor that beast. That's 84. Factors of 84 that add up to be 30? I don't know. I don't know. Leave it. Yeah, let's just leave it. Okay. So usually, why am I saying leave it? Usually in calculus, I'm not, so I am concerned that you know your algebra. But what we're trying to do right now, I don't, we've spent a lot of time on algebra. So what I'm concerned with is that you can do calculus. Can you do the quotient rule? So that's what we're talking about. We're not talking about algebra today. We're talking about calculus. So I want to see, can you do the product rule, this guy? Can you do the product rule and the quotient rule? So this is the quotient rule. Okay, well let's try the next one. So here, f. So let's take the derivative of f, number 1 down here. This one's going to use the quotient rule because we have a fraction here. So remember what the formula says. It says low, the denominator, d high, the derivative of the numerator is just 1, minus, quotient rule says minus. So this is low, d high, minus high is just x, d low is 1, all over the denominator squared, that's low squared, just like that. All right, yeah, you can simplify if you want. Ooh, it does simplify. Simplify is kind of nice, I think. What do we have? It's just going to be 1 in the numerator over x plus 1 squared. Yeah, how about that? The x's cancel. The x's cancel. Let's try number 2 here. So number 2, f prime. Okay. So let's see. So we want low. You always start with the denominator. Low. D high, the derivative of the numerator is 1. You don't have to write that 1 in there. I'm writing it in there so that you can see that I'm actually multiplying by the derivative of the numerator. But the derivative of this x right there is just 1. Remember, the coefficient is 1. So you're just multiplying by 1, which really doesn't change much. And now let's say the formula says low d high minus high. That's x minus 1. D low. So that's 2x plus 2. That's the derivative of this guy down here, the denominator. This is all over the denominator low squared. So the denominator squared. That's it. So it's kind of a mess. I don't like the quotient rule, and I remember the very first time I learned it, I kind of shirked it a little bit. Is like, I don't want that. I don't want to know it. Is there another way? Please tell me there's another way. But I would suggest that you know it. I would suggest that you know it. Take it from me. It's going to save you in a place or two just because it's a lot of work to avoid using the quotient rule. Okay. Well, so now maybe you will want to pause the video a little bit and try some of these examples on the next page. So the products, like number 1, is going to use the product rule. Number 2, product rule. Number 3, it's a fraction. We're using the quotient rule. Number 4, we're using the quotient rule. 5 and 6, both quotient rule. So maybe give some of these a try, and then when you're ready to continue to the next part, maybe unpause the video. Okay, well, maybe you tried some of these problems, so let me write down the answer for a couple of them. Let's see, like number two looks bad, so let me try number two. So the first function, he gets his derivative first, while the second one, this guy right here, waits. He's waiting to get his derivative. Then the product rule says plus. The product rule says plus. Now, this guy waits. The first function waits, while the second one gets his derivative. It's his turn now. So the derivative is 4x plus 3. Yeah, that's it. So that's the answer for number two. I would leave it. If you expand it, it's going to be a terrible mess. Just leave it alone. Yeah, let's see. Is there another one that looks bad? Let's try number five down there. Number five looks bad. So remember what the quotient rule says. This is the quotient rule because there's a fraction. So the quotient rule says low d high. So the denominator, d high, the derivative of the numerator is going to be negative 2x minus 2 minus high, that's 3 minus 2x minus x squared. So no derivative on high. D low is just 2x all over the denominator squared. There it is. Yeah, leave it alone. Don't touch it. If you touch it, it's going to fall apart. Um, I just leave it. I don't want to simplify it, and you probably don't either. Like I said, we're just trying to learn the quotient rule and product rule right now. I believe you can do algebra. I believe in you, but right now we're not learning algebra. Okay. Well, let's look on the next page. Um, all right. So remember how I said that the derivative actually has to do with the tangent slope? So the derivative means tangent slope. Derivative means tangent slope. So here we have the derivative in this picture. We have the derivative of some function g, and so what this tells me is the slope of g at any point. Slope of g at whatever point you want. So let me show you what I mean, for example. Let's go to something like, let's go over here to 4 and go down to this point. What is the slope of the function g at 4? Well, the slope is negative 2. The slope of the function g at 4 is negative 2 because g prime tells me the slope of g. So we could say something like the slope of g at x equal 4 is negative 2. Yeah. So that's what the derivative does for us, is it tells us slopes at different places. So let's look at example 1 and see what they say. It says on what intervals of g is g prime increasing? So this graph right here, this picture is g prime. So notice that g prime is increasing right here, and right here. So let's write down those intervals. So we're going to say it's increasing on negative 3 all the way to right here, which is 1. So I typically use open parentheses. I don't use the brackets. It's not wrong if you use brackets, but typically I use open parentheses for intervals of increasing, decreasing. And then we want to continue right here, picking up at 4, and we want to go to 7. There we go. So that's the interval where g is increasing. Now, something that would be good to discuss that's not on here that I kind of feel like is important to discuss is where, let's say, on what intervals is g increasing? You might say, well, we don't have a graph of g. We only have a graph of g prime. We only have a graph of the slope of g. Well, notice that when the slope of a function is positive, that means it's increasing. Do you see how the slopes are positive here? That means a function's increasing. So where is g prime positive? Because wherever g prime is positive, that's going to tell me where g is increasing. So let me say that again. Where is g prime? That's the slope of g, remember. Where is g prime positive? Well, let me clear off my graph here. So g prime is positive. Is g prime positive here? No, because g prime is negative here. That's the value. So if I keep going up, right here, g prime is 0, and then these are the positive values. So these positive values are where the slope of g, the original function, not g prime, but where the slope of g is positive. So on these two intervals, that's where g is increasing. So we could say, to answer my question, the question that I made up there, we could say from -1 to 2, and then we could pick back up from, let's see, this point right here is at 6. So 6 to 7. Yeah, cool. Okay, well, let's answer the next one. Where is G prime decreasing? So they're talking about G prime here. So G prime is decreasing where the slope is negative, the slope of G prime. So there it is. So we'll say decreasing on, let's see, that's going to be the interval from 1 to 4. That answers number 2. On what interval is g prime bigger than 0? Ah, we already answered that one right here. So notice where g prime is bigger than 0, that's where it's above the x-axis, those two spots right there. So we already answered that. That's from -1 to 2, and then picking back up right here from 6 to 7. Yeah. On what intervals is g less than 0? Well, let's see if we can find that here. So here it's everywhere that it's not bigger than 0. So here it's less than 0. The graph is below the x-axis, and here it's below the x-axis as well. It's everything below the x-axis. Anything down here is going to be negative. So let's write those intervals. That's from -3 to -1, -3 to -1. We want to pick back up over there at 2 to 6, so then 2 to 6. Yeah. Problem number 5 says, what are the zeros of g prime? So let's look up here. So we're looking at the graph of g prime. We want to find, what are zeros again? Zeros are also known as roots, or where the or x-intercepts. So you want to find these x-intercepts of the graph. So here's 1, 2, and 3. So we want to write all of those down. Zeros are written as x-coordinates, so we can just say x equal -1, and x equal 2, and x equal 6. So x equal 1, -1, x equal 2, and I think I said x equals 6. Let's check. -1, 2, and 6. That'll work. What is the slope of g prime from 4 to 7? The slope of g prime? Oops. Well, let's have a look up here. So we're from 4 to 7, so we rise and run. So the rise from -2, count up, 1, 2, 3. So we rise up 3 and we run 1, 2, 3. So the slope is just 1. So the slope, they say that, what is the slope of g prime? So we'll say slope of g prime on 4 to 7 is 1. What's the average rate of change of g prime from -3 to 7? So that's an interesting question. Average rate of change is it's a fancy word for secant slope. the secant slope. And if you remember, we talked about secant lines. Secant lines are just lines that cross a curve in two places. Or you could just say average slope. Average slope. So any of those mean the same thing, average rate of change, secant slope, average slope. So what we want to do is find the slope from this point all the way to 7. I think they say from -3 to 7. Is that what they say? Yes. So we want to do rise over run again. So rise up 5 and run 10. So the average rate of change is rise, which is 5, over run is 10. So average rate of change secant slope is equal to 5 over 10 rise over run is 1/2. That's the average slope, or the average rate of change of g prime on the interval. Write a piecewise equation for g. That's kind of a difficult thing to do. So we want to write a piecewise function for g prime. Let me erase all of this so that we can see what we're talking about here. So let's write an equation for this line right here. So notice that the y-intercept up here would be 2. So this is 0, 2. If I were to extend that line, and it looks like the slope is rise up 2 to the right 1. So rise up 2 to the right 1, rise up 2 to the right 1. So the slope is 2. So the equation for this line, the slope is 2. So we have 2x, and the y-intercept is 2. What am I using? Y equal mx plus b. So the slope, I used rise over run, which is 2 over 1. And then I use the y-intercept, which is 2. This is the b, to create this line. So this is the line 2x plus 2, and that's for whenever x is less than -1. So x less than -1, let's write this, x less than, oops, I got to write that the other way, x less than -1. And we want the line 2x plus 2. Okay, let's find the next piece. Let's find the next piece. Okay, so the next piece is this piece right here. And the slope for this one is rise up 1 to the right 2. So the slope is 1/2, and the y-intercept is 1/2. Notice, do you see where it crosses there? So we want y equal mx plus b. And so the slope is 1/2. And the y-intercept is 1/2, so we want 1/2 x plus 1/2. And that's on the interval from -1 to 1. So when x is in between -1 and 1, we'll put an equal to on both of those. Then we have 1/2 x plus 1/2. Why did I put an equal to there? It doesn't matter where you put the equal to's. In this case, since it's a continuous function, at the endpoints it's defined there. So that's fine. Okay, well let's do the next one. Let's do this line right here. We could find the y-intercept here. It looks like the slope is rise -1 to the right 1. So the slope is -1. So if I continue over, that's going to give me a y-intercept again of 2. So the slope is -1. We want y equal mx plus b. The slope is -1, and the y-intercept is 2. So the line is negative x plus 2, and we go from 1 all the way to 4. So from 1 to 4, so let's say x going from 1 to 4. I've put an equal to up here, so I can't put an equal to right here, so I can't put that there because that would be double defining the function, but I do need an equal to on the 4 there. I've already put the equal to on 1 up above in the previous function, but we want minus x plus 2. All right, I think we have one last piece for our piecewise function. Let's see if we can get that defined there. I have to slide that back down. Whoops. There we go. So let's erase this. And okay, so now we want this last piece. I'll use green here for this one. This one has, I wonder what the y-intercept is going to be. Golly, I don't know what the y-intercept is going to be. You could continue. Remember, we already found that the slope of this line is 1, so you could continue it all the way down to find the y-intercept. Or you could just find the slope. We already know that the slope of the line is 1, and then you want to use y minus y1 equal m times x minus x1. Do you remember the point slope formula? Point slope formula? So what we want to do is you can use either one of these points. It doesn't matter which one you use. I'm going to use 4, -2. So this is going to be minus -2. The slope we found was 1, and the x is 4. So now let's just, this is y plus 2 equals x minus 4. We'll subtract the 4, or the 2 over to get x minus 6. So that's y equal x minus 6. X minus 6. And that's when, let's see, when x goes from 4 to 7. So from 4 to 7, x going from 4 to 7. And I can't put an equal to here. I have to put one here, though. So the reason I can't put one on that 4 is because I've already put it up here. So no equal to on the bottom 4. My goodness, that was a difficult piecewise function to put together. Let's look at, well, it's just lines, I guess, but it took some work. Let's look at number 9. At what values of x does g have a local maximum? So we want a local maximum of g prime. So g prime, if I go back up here and look at g prime, we want where its maximum or where the function reaches a peak. So we're talking about g prime here. G prime reaches a peak right about here. That's a local maximum. Also, the endpoint right here is you could consider to be a local maximum as well. What does it mean to be local? Well, if you draw a circle around that point, are all the points in that circle higher than it or lower than it? Notice that all the points on the line in that circle are lower than that point, which means that those are local maximums. So I'm going to say local maximum at x equal 1 and x equals 7. So let's write that. Local max, local max at x equal 1 and x equals 7. Yeah, they didn't ask for the value, or they say at what values of x. They didn't ask for the value of the local maximum, which would be the height. They didn't ask for the height. How high does it go? They say what values of x does g have a local minimum? So we want to do the same thing here. So notice right here, if I do a small circle around this point, all the points on the graph are higher than that point, which tells me that that's a local minimum. And if I do this point over here, this point is also, all the points are higher. So that point is also a local minimum. So let's put those 2 points down. That's x equal -3 and x equal 4. So we want local min at x equal -3 and x equal 4. There we go. Yeah. All right. So you should be able to do the next worksheet here. This is a little different than the problem that we did. Notice that we're not talking about f prime, but we're talking about f here. And some of the things that they ask you to find are the values of the functions. They ask you to still find the zeros where f is increasing, decreasing, find local max and mins, and where is the function positive, where is the function negative, and where is what is the slope, what's the average rate of change. So some of these questions are very similar. Some of them are different, but go ahead and give these a try, and then we'll talk about them either next time or well, I mean, I could just do them right now. So if you want to pause the video and try these on your own, and then when you're ready to continue, you can unpause it. Okay, well, let's look at a few of these. Let's look at 13. It says draw some of these odd ones down at the bottom. Let's look at those. We haven't talked about concavity in our example, so maybe um, let's look at number 11. So number 11, on what intervals is f concave up? So concave up means that if it were raining, the graph would hold water. So imagine it raining. Maybe I'll have it raining straight down like this. Um, is the graph going to collect water, or is it going to let water run off? And the water is going to collect there, which implies that it's concave up. So I can see that it's concave up from here all the way to here. So it is concave up on 0 to 6. So they ask what intervals is it concave up? 0 to 6. On what intervals is the graph concave down? I actually don't see any time that it's concave down. The graph right here is a straight line. Straight lines do not have concavity. Concavity is a measure of bending and turning. And so this line here has no bend in it. It's not bending at all, so there's no concavity. And we've already seen that this is concave up here because it collects water. So that would not, that's not what we want. So we'll say none. None or no interval. Okay, number 13 says draw a line that is tangent to f at x equal 1. Is the slope of this line positive or negative at x equal 1? Right here. Okay, so that looks like what a tangent line would be. So I'm going to say tangent line at, we'll say at x equal 1. Now, what does it mean to be a tangent line? It touches at the graph at one point is what we'll say. So touches the graph at one point. Now it's true that it touches over here, but we're considering what in mathematics what we would say locally. So locally here, it's only touching the graph at one spot. So I don't care if it intersects the graph somewhere else, but only locally around that point it touches the graph at one point. Yeah. Okay. So what does it appear that the slope is? Is this a positive slope or a negative slope? Well, it's going down and to the right. So that would be a negative slope. So negative. At what values of x would f have a horizontal tangent line? Well, horizontal tangent line means that the slope is 0. So maybe let's say that horizontal tangent line means slope is 0. So let's go back up to the graph here and look to see where on this graph is the slope 0. And to me it appears right about here the tangent line would have a 0 slope. And so that would be at x equal 3. So at what x values, there's only one, x equal 3 is the value that I see. Yeah, so some of those are some interesting problems. I will have an answer key posted up for these other ones on Blackboard if you want to check those out. Hopefully this was helpful to you. Hopefully it made sense. If you have finished both of those worksheets, you can actually start on this review. Unit 10 review, we only have a quiz on Unit 10. We don't have a chapter test. So if you're a senior, you're not going to be taking the Unit 10 quiz. You're going to be taking the final. So you'll be studying for the final there. But everybody else, underclassmen, you guys will be preparing for this quiz on Unit 10 material. So you want to go through these problems. That's only those two pages there. Are there some practice problems? Yeah, there's some practice problems with derivatives here as well. Okay, well, I will see you guys not tomorrow, but I think later this week, 6th period. I might not actually see you at all this week, so it might be until next week that I see you. All right, well, I'll see you next time.